My name is Laura Catalina Alco. I'm the product manager for remote sensing instruments software in Vaisala. Today, I will talk about the benefit of weather radars and the importance of integrating these systems with other remote sensing information. Let's get into the subject. Weather radars are essential elements of a modern weather observation network. Radars provide accurate information on various hazardous rainfall-related phenomena, such as severe thunderstorms and tropical cyclones, both of which have significant societal impacts. Weather radars are versatile instruments that provide benefit in a number of application areas, including, for example, generic weather surveillance and forecasting, hydrology, climatology, aviation, agrology, and the energy sector. These systems have three main benefits. They provide high resolution to detect highly localized and rapidly evolving phenomena. They also give great coverage that allows to detect phenomena at different scales. In this way, we can monitor from local storms and hurricanes. And one of the most important advantages and versatility of these systems since they allowed us to estimate various characteristics of the events. For example, the amount of rainfall in a quantitative way to improve the forecast, the potential of flooding, or to identify types of precipitation. In generic weather surveillance, for example, in remote monitoring or of intense rainfall, a good coverage of precipitation measurement is essential. With sparse of missing meteorological observations, weather forecasts will be erroneous, or they cannot be provided at all. Weather radar is an efficient instrument to provide overall observation and forecasting capability of this precipitation. Thanks to the extensive coverage, the weather radar information allows monitoring of large-scale systems such as a frontal weather system or tropical storms. Modern weather radars can also detect small-scale events such as localized convective storms that can have significant consequences at the ground level despite their small size. One of the main benefits of a modern weather radar is the capability to detect several hazardous phenomena associated with a storm or other precipitation systems. Doppler weather radars provide information about intense winds, wind shear, and additionally, dual polarization technology enables then the identification of precipitation types such as hail or graupel, which is associated with the lightning activity of the storms. In addition of being able to locate rainfall areas, weather radar can estimate rainfall intensities and accumulations quantitatively. Radar-based information is also valuable in heavy rainfall and flood forecasting applications, particularly in the time scale of 0 to 6 hours, which is also known as the nowcasting time scale. A rainfall forecast extended up to a few hours into the future is usually the most critical indicator in hydrology towards forecasting the potential risk of flooding and especially flash flooding. Weather radars are the most important tool to fill in gaps of the conventional forecasting models. The ability to provide accurate short-term rainfall nowcast is particularly important for flash flood forecasting, where the conventional weather models might not be able to accurately present precipitation fields with adequate spatial accuracy. With the weather radar data, we can help to understand climatology of the meteorological phenomena, which is needed especially in understanding and predicting of high phenomena such as tropical cyclones that are predicted to go through still unknown changes in the tracks, frequency, and magnitude driven by the climate change. These systems can also detect volcanic plume and eruptions, assuming that the radar has reasonable location in relationship with the monitor volcano. Monitoring volcanoes through weather radars can efficiently complement seismic detection systems in eruption cases that do not produce any seismic signals. Dual polarization information provides additional information on the structure and composition of the eruption. For example, it can help to identify the main eruption column and the ash column separately. Meteorologists and forecasters have the fundamental task of providing accurate data and model-based predictions for different purposes, such as early warning systems. The acquisition of information from various sources is necessary to ensure good initial conditions and more accurate predictions. Data from remote sensing systems has increased its use and credibility for this purpose. For that reason, in addition to the weather radars, information from other remote sensing, such as high precision thunderstorm sensor data, LiDAR, global storm and satellite data are vital for ensuring more precise and validated information. High precision thunderstorm sensor data, for example, provides information on electromagnetic activity in the unstable atmosphere, allowing them, as a result, to have an indication on whether or not your assets are exposed to any type of risks. LiDAR systems give us information on the wind condition in certain areas, generating information on the development of turbulence and atmospheric structures. These instruments are excellent for monitoring events without the presence of precipitation, but they can also provide information on an emerging localized event. And finally, the global storm and satellite data provide information about systems that are developing outside the range of the observation of all this in situ information. The information of these systems and the relationship between them assure having meaningful data. However, meaningful information without a way to present it and combine it does not provide any added tools for decision making. Having a reliable, flexible, and secure application software is just as important as having each one of these components to produce the data. In this day and age, a way of accessing and interacting with data from any source is a necessity. Information technology and software have become a key factor in practically any device, and remote sensing instruments are not the exception. And with IRIS Focus software, Vaisala is providing to meteorologists and forecasters a powerful tool to analyze current and past atmospheric conditions. Independently of the technology that you have in use, the most important element for severe weather detection, accurate forecasting, and a proper input for decision making is the data availability. So, when adding to your meteorological infrastructure any device or software tool, make sure there is a proven history of these systems working in adverse conditions to make sure you will have your data when you need it. As a summary, meteorological remote sensing instruments provide substantial added value to the monitoring of various significant weather events. The integration of various remote sensing systems is essential, in addition to the quality of each individual instrument. Vaisala remote sensing offering provides an integrated solution to support the high impact weather monitoring. Thank you all for your attention.